Hi, I'm Hannah. Welcome to Crash Course Biogeochemical Cycle. Ever heard of this Wonder Pets episode? No? Well, our topic in this episode is ponds. Yeah, time to introduce this little guy here. Ponds are generally known to be typically smaller than a lake. Their formation can either be natural or artificial. And while most ponds contain fresh water, they can also be filled with water from rain, groundwater, or runoff. Aside from that, although they are known to be smaller than lakes, they still can support a variety of living organisms like plants and animals. Now, let's talk about what keeps a pond's life healthy and full of life. We can identify 4 cycles that happen in the biogeochemical cycle in a pond.
Miss Hannah, what's a biogeochemical cycle?
Yes. Always skip the most important part. What actually happens in a biogeochemical cycle? Such a fancy word, but is it really that important? Humans. Yes, we benefit from this biogeochemical cycle the same way various organisms do. It serves a crucial role in ensuring that a life is sustained through the continuous recycling of chemical elements necessary for living organisms. Now, let's get back to ponds and ponds again. The biogeochemical cycle that takes place in a pond includes these 4: nitrogen, carbon, phosphorus, and water cycles. Let's try to give a little bit of a background for these cycles in the context of ponds, shall we? Okay. Let's dive first into the nitrogen cycle. For this course, we will divide it into 3 important parts: nitrogen fixation, nitrification, and denitrification. In a pond, the fishes release waste, which has ammonia, a really toxic chemical. This is then turned into nitrates and nitrates through nitrification, making it less toxic. Finally, through denitrification, it turns into air that plants can use. The carbon cycle in a pond has a much simpler explanation, which is the photosynthesis in plants. Plants and algae in a pond use sunlight and carbon dioxide to make food. Then they produce oxygen, which they would release both in the atmosphere and in the water. Now onto the phosphorus cycle. It is basically the weathering of rocks due to its environment and the decomposition of aquatic animals. Weathering of rocks releases phosphorus to the water, which is absorbed by the organisms in it, and when these organisms die, phosphorus returns and can become sediments that sink to the bottom of the pond, forming rocks. And the cycle repeats. Lastly, the water cycle. It is pretty simple. Water from the pond evaporates, water from the plants transpires, and all of this water condenses into a cloud, then precipitates or rain, returning water back to the pond. However, with this biogeochemical cycle comes the altered biogeochemical cycles. Let's dive deeper into that. Recently, human activities and environmental changes, most of which are from man-made activities, resulted to the changes in the natural cycles of these elements. When we cut down trees, use more cars, and build more buildings, the natural circulation of these elements such as nitrogen and carbon changes. Let's look into the possible changes in these cycles when Baguio City was hit with super typhoons in the year 2023, specifically the possible changes it may have caused on the iconic tourist attraction Burnham Lake. The city of Baguio is situated on a typhoon belt and experiences an average of 5 tropical cyclones annually, bringing extreme rainfalls and high wind speeds. In fact, in the year 2023 alone, Baguio was hit by Super Typhoon Igay, also known by its international name, Doksuri, which forced the declaration of a state of calamity, and Super Typhoon Betty, also known by its international name, Mawar, causing heavy rains and leading to a higher possibility of soil erosion and landslides. The alteration of nutrient dynamics may be a consequence of these super typhoons. The intense rainfall during these super typhoons may lead to an increased runoff, increasing sedimentation, and transporting high loads of nitrogen and phosphorus into the water. The fluxes in these typhoons may contribute to the nutrient inputs, which may alter the biogeochemical cycle of these ponds. Let's explore one of the cycles, the nitrogen cycle, and see how the super typhoons may affect this. When super typhoons occur, the average lightning density is twice as large as opposed to weaker typhoons. Through the combination of nitrogen gas, which are broken up during lightning storms, and oxygen forming nitrogen oxide, nitrates can be added to the pond. The influx of these nitrates during super typhoons leads to temporary spikes in nutrient levels, which influences algae growth or bloom after a storm and generally alters the biogeochemical cycle. However, this may be counteracted when some liquid bacteria are added after a storm. Super typhoons can have detrimental effects and may disrupt and alter the natural cycles of these elements. This may lead to ecological consequences and changes in the biogeochemical cycle, which ultimately leads to vulnerability of biodiversity and human health and food insecurity.
The pond's biogeochemical cycle is all messed up. If we don't help, the pond becomes uninhabitable.
This is serious.
We need to reduce nutrient runoff, use eco-friendly fertilizers, plant buffer zones to soak up extra nutrients, keep waste and sewage far from the pond.
And we must prevent pollution. No dumping plastics or chemicals. Use eco-friendly products.
We also need more oxygen. Install aerators and fountains. Add oxygen-producing plants. Use fish to control algae blooms. And let's manage temperature and pH. Shade the pond with trees. Monitor water chemistry. Reduce CO2 pollution.
Finally, let's get the community involved. Teach people about water conservation. Promote eco-friendly habits. Support conservation efforts.
Teamwork saved the pond. Now the fish can breathe again.
And no more smelly water. You're welcome, pond.